The overall goal of the following procedure is to create a mechanical vessel injury in zebrafish embryos. This is achieved by puncturing the caudal vein of the zebrafish embryo using a minutia pin. Next, hemostasis is assessed by measuring the amount of time blood is actively flowing from the wound. Then, time-lapse microscopy is carried out to visualize aspects of wound healing such as vessel repair. The results show that mechanical vessel injury in zebrafish embryos can be used to reproducibly measure aspects of hemostasis and wound repair, such as bleeding times and the time it takes to re-establish blood flow.
The main advantage of this technique over mouse and other standard injury models is that in the zebrafish embryo, inflammation, hemostasis, and repair can readily be visualized using real-time microscopy.
To begin, insert a minutia pin into a pin holder and clamp the pin. Using fine forceps, carefully bend the tip of the pin to create a slight hook. To manipulate and stabilize the embryo during injury, use needle nose pliers to bend the end of a 28-gauge 1/2-inch needle mounted on an insulin syringe. Next, prepare zebrafish embryos by setting up breeding pairs and collecting eggs in egg water as shown previously. When the embryos reach 8 to 24 hours post-fertilization, or HPF, add PTU to the egg water to prevent